go. Okay, so volume, the first type of volume we're going to look at are for prisms. Okay, prisms are a polyhedron with two opposite ends called bases that are parallel polygons. Okay, so let me get my box of shapes out here. Yes. So, prisms, for example, their sides, what we call the lateral sides, are always rectangles. Okay, these are always rectangles. The ends are some type of polygon. It could be, like in this particular case, you have an octagon, right? And so if it's an octagon, it's got 8 sides, that means you got 8 rectangles on the sides there. So, like this, for example, what shape do we have on the end, the base? Hexagon, we got 6 sides, and notice rectangles on the sides, right? So we've got that. What have we got here? Triangle, so this is a triangular prism. Notice sides are rectangles, right? What about this thing? Is this a prism? It is not, because are the sides rectangles? They are not. We actually don't have to do that one. I don't think that one's a... I think that's a dodecahedron. There's 12, yeah. We don't have to do that one. This one, we got a square, sides are rectangles, or anytime you have just a box, right, we could have rectangles. These could be our bases, and then all of these could be our sides. It really doesn't matter which side you call the base on a rectangular prism, because everything's a rectangle on this, right? These technically are squares. Squares are just types of rectangles. So this is the only one. It doesn't matter what you use for your base. For that, let's see, there's another triangle. How about this one? What's that? That one's a pyramid. Is this a prism? It is not, because are your sides rectangles? They are not. How about this one? It's a cube. It is a special kind of prism, right? Because this is a rectangular prism. This is also a rectangular prism, but it's a special kind called a cube for that. So I think that's my prisms in there. So we'll look at more here in a second. So for the volume of a prism, it is always the area of the base times the height. Okay? So area of the base times the height. And there are a lot of types of bases that you can have. Okay, so let's do this with our note card. Okay? Oops. Not me. Let's put a few things together here. Okay. Gracious me. Okay. I won't. So we'll put probably want to write fairly small because we'll have lots of things to add to this. So I put volume of prisms here. And so you can see what I'm writing. And I'm going to split screen this with this. But I really don't, actually I'm going to do this. Make that full screen. This. Over top of it. Okay. Alright, so for our volume of prisms. This is the area of a triangle, right? So area of a triangle is 1/2 little b times h. Okay? So if we have a triangular prism, first of all, it will probably be helpful to actually draw a picture of a triangular prism. This is where your art skills come in handy. So I'm going to try to show you how to draw one. If you want to draw a triangular prism, I would start with a triangle. Right. And then draw a couple lines that are the same length off of that triangle. And then just connect here. If you want, you can put like the dotted lines inside, but we'll try to keep it as simple as possible. Okay? So, if you have a triangular prism, okay, the volume is always the area of the base times the height. So the area of the base is going to be 1/2 little b. Oh gosh, I don't like that though. I need to rethink this just a little bit. Here's the problem. Is this base time, we did 1/2 base times height, right? We've learned that a bunch of times. But we also have to have a height of our prism, right? So we're going to call this right here our little b for our base. I want to call this side right here the height of my prism. So I don't want to call the height of that triangle height as well. It's not going to be the same number. So I'm going to call this right here, I'm going to call it A for altitude. Okay, so if I'm finding the area of this triangle, it's 1/2 B times A. Times the height of the prism. Okay, so you're just finding like the area of the triangle, and then you multiply it by the height of the prism. And let me zoom back out so you can see it. All right, so we got our triangular prism. Okay. Next, let's do a rectangular prism. I might have to give you more than one note card on these if we're going to do it this way. Let's see. All right, let's draw a rectangle. And then you're going to draw 3 little lines from each corner. You want them to be about the same length. And then connect those. Oh, like that. Here. Let's fix that. Let's make these lines a little bit longer. I don't think I made them long enough. There we go. So we got this rectangular prism here. And so if you're looking at your base right here, we could call this length. Actually, the base would kind of be on the bottom normally, but and width, and we could call this height. All right. So the volume for a rectangular prism we've already done. It is, the most simple that you'll have. The area of the base is length times width, and then you'll multiply that by height. And on a rectangular prism, it really doesn't matter which side you call the base. It could be any of the sides. you don't have to do this next one because we could just use a rectangular prism for it, but sometimes it makes it a little bit easier. Let's do a cube. So like if your base is a square and you have the same height as well. So if you have, I'm going to write that this is a cube so we know. I guess I could call that rectangular prism and triangular prism. Should write that first. All right, so for a cube, you want to draw a square. All your lines the same length. And then connect there. Not my best work, so I fixed that a little bit. Okay, in a cube, what do we know about all the sides? They're all the same. So we could like label this S, we could label this S, we could label this S, or you could use whatever variable that you want right there. But all the sides are the same. So volume is just going to be side times side times side because our length, width, and height are all the same. What's another way I could write that? Instead of doing S times S times S. S cubed. So that's a little bit of like a shortcut for those. Okay, everybody good here? All right, let's do I guess that's called a parallelogram prism. Parallelograminal. Let's just do parallelogram. So for this one, draw yourself parallelogram. You'll have lines from each side and connect those lines. Okay, a lot like our triangle, where this tells us base times height, because that's typically what we do for a parallelogram. I don't want to call height here because that will be confused with the height of the parallelogram or of the prism. So I'm going to call this right here A, like I did before, and I'm going to call this little b. And then this part would be my height. So for that one, our volume would equal our base times our altitude times our height. Okay, and a trapezoidal prism trapezoid has to have two sides that are parallel and the other two that are not. And again, a lot like the other ones, we don't want to call that height right there. We want to call it something else. I'm going to call it A. And a trapezoid has two bases. It's got a longer base and a shorter base. Oh, we haven't even, hold on. I don't need to label this till we've made it a prism. It's not a prism. Draw your little lines. And then connect the ends of those lines. This would be B2, and then this part right here is your height. Okay, for a trapezoidal prism, it would be the area of the trapezoid. For a trapezoid, that formula is 1/2. We usually say height, but I've called it A here, not to get it confused with the height of the prism, times B1 plus B2, and then we'll multiply that by the height. There might be one more we need to add later, but I don't think we have to do, I don't think we have to find the volume of like a octagonal prism. We have to know things about it, or they might give us the area of the base and ask us to find that, but I don't think we'll have to have it. So we should have these 5 here on our note card. So everybody got a note card? Got it down. We're going to have it. We're going to keep up with it. Okay. So let's look at some things that you will be asked to do here. Actually, first we need to fill in down here at the bottom. It is really important that you know the bases are the sides that are not rectangles. Except for in a rectangular, what happened? Where'd it go? Oh, good gracious. A rectangular prism, where all sides are rectangles. Okay, so, one thing that's really important is you got to be able to tell what a prism is so that you're using the right formula. Okay, so looking at this picture here, raise your hand if you can tell me one of them that is a prism. What you got, Lily? Which one? E. What type is that? Triangular prism. Okay? All right, somebody else. What have I got, Trinity? B? What type is that? Rectangular prism. And somebody else, my last one. D? What type is it, Angel? Trapezoidal. Prism. Okay? None of the others are prisms. We're good here? Alright, let's do some problems where we find the volume. Alright? So, that first one like my kids in elementary school bring home. So this one is just a rectangular prism. It doesn't matter which side is your base because they're all rectangles, right? So for this volume, what do I have to do? First I need to get rid of that. Length times width times height. So for this one, that's going to be 7 times 5 times 3. All right, and 7 times 5 times 3 will give us 95. No, 105. 105. Okay, now one thing that is really important for this is that you know your units. That's really going to be important when we start doing density and things like that. So volume is always going to be in cubic units. So we're doing centimeter times centimeter times centimeter. That gives you centimeters cubed. So make a note there. Volume is always in cubic units. Okay. All right, so some of the problems will be as simple as this, right? Length times width times height. Others, like number 2, are a little trickier to decide what numbers to use because they've given you a lot of information for number 2, right? And first of all, the first thing you have to do when you're doing a volume problem is figure out what type of formula you're going to even use, right? So if we look at our note card over here, let's move our, let's see, that's not what I want. This. Move our note card over here. Which one are we looking at there? What type of shape have we got? Triangular prism. So we want to use this formula right here. Volume equals 1/2 base times the altitude times the height. Now, the problem is this triangular prism turned the same way as the one that we drew. It is not. So this is where kids start to get confused because you're like, turn it, you got to turn things in your mind. So first of all, we need to figure out our formula over here is volume equals 1/2 little base times the altitude times the height of the prism. Okay? Now, this part right here comes from the base of your prism. What shape is the base for this? 5 is going to be part of it. So what shape are we looking at for our base? We're looking at the triangle. Either the top or the bottom, doesn't matter. Okay? The bottom one has more of what you need, but you actually have to put things together here, right? Because in this picture that I have over here on my note card, that B and that A must be, I probably should have drawn this on my, they must be perpendicular to each other. I can put a little square right there showing that's a 90-degree angle. They have to be perpendicular. So what's a little weird about this is it's all turned around funny, right? So for this problem, the altitude of this triangle has to be this piece right here. That has to be your A, your altitude of that triangle. What is the base? It's got to be the side perpendicular to it, right? So this side right here has to be the base. But it's not marked on the picture, but we can figure it out. What is it going to be? It is going to be 5, because if this side right here is 5, then this side parallel to it right here has to be 5 as well, right? So we've got our A and our B. What's our H? Okay, it's going to be 4. Which 4 are we looking at? This 4 on the bottom or this 4 on the side? The side 4, right? Because what you want to think about every time, no matter what you're dealing with, and this one's already set up that way, for the height of your prism, for that last number, you want to think about taking the picture and turning it so this is the base, and it's going to be how tall it is up off the table, right? Now, this one's already drawn like that, so this side right here is your height. Sometimes that is confusing because what the height off the table is different. So once you get these down, you got A, B, and H, it is pretty easy. Figuring out what those are is what kids have trouble with, because now we just plug it into our formula. So our formula is 1/2. We're replacing B with 5. We're replacing A with 1.5. And we're replacing H with 4. Okay? And we just have to type that into a calculator. So 1/2 times 5 times 1.5 times 4 is giving me 15. So we get 15 cubic yards. Okay. There are so many places in like real life where this applies. For example, cubic yards is usually how they're going to measure things like dirt and soil whenever you're like buying it in bulk to like if you're buying like mulch for something. Now, if you are just buying mulch for your yard, you can go to the sawmill and tell them that you want 1 scoop or 2 scoops or whatever, or you could buy bags at Lowe's, I guess, which will probably have cubic yards on it there. But if you are, like my husband used to work in Wilkesboro for the DOT in the construction office, and in fact I got a couple kind of cool problems from whenever he did that, and like he had to go over the plans because when contractors bid out a job, so whenever they're putting in their bid to do this job for the state, a lot of it would include things like mulch because whenever they like for example if they're doing a rest area they have to like landscape stuff, so they have to put in the cubic yards of mulch and how much they're charging per cubic yard, and so they got to find the volume of different areas that they're looking at for that. So he would see that a lot, and his job was to like check over that and make sure their estimates were accurate for the job for that. So there's lots of places where you could do this. If you're just putting mulch out in your yard, you're probably just going to go get some, put it out. If you need some more, go back and get another load. But if you are bidding out a multi-million-dollar contract for a rest area or for some type of road, definitely more important to be precise. Because if they bid out that they're going to do this job for $4 million and then it ends up costing them a lot more, they're going to lose money on that job. You can't bid it too low or you'll be in big trouble for that. So, let's keep going. All right, now, let's talk about a cylinder. A cylinder is almost a prism. Okay, think about these two. In fact, we're going to think about some calculus right here. This and this look pretty close, don't they? This has rectangles as its side, but, you know, the ends look almost a little like a circle. What if I took this and I had like 12 sides instead? The end would look even more like a circle, and each rectangle would be smaller, right? It'd be smoother as you go around. What if this had 20 sides, right? Then it got teeny tiny little rectangles all around. If I had 100 sides, it would just be like a bumpy cylinder is what it would look like, right? It'd be almost a circle. And if you have infinite sides, which isn't possible, but if you did, it would be a circle, right? You can kind of think of just adding more sides until you get a perfectly smooth circle. So this operates basically like a prism, right? It's still just the area of the base times the height. But for a cylinder, your area of the base, right here, is pi r squared. That's our area of a circle. So a cylinder is a three-dimensional shape consisting of two parallel circular bases joined by a curved surface. Okay, we need to add this to our note card. I am out of room on my front side. I may have to let you guys have more than one note card. It might be too much for one. Let's see. But let's add this cylinder. Okay. All right. Now, to draw a cylinder, you can draw like a oval, two sides. If you can't draw an oval, then I feel sorry for you. And then just a curved bottom part. Okay. In the cylinder, what you need to know is the radius. So we can label this right here R for our radius. And you need to know H, which is your height of the cylinder. And our volume is the area of the base, which is pi r squared, times the height. Okay, we okay here? Everybody got that on their note card? All right, so we're finding the volume of this cylinder here. So our volume is going to equal 1/2. Oh, I don't know why I'm doing 1/2. Losing my mind. All right, pi times the radius squared. What is my radius? 8 squared times the height. What is my height? 15. Okay, now let me show you something they're going to do quite a bit on this. Sometimes they do not type the whole thing in for the answer. Sometimes they leave pi in the answer. And actually, if you got to do more calculations with it, it's easier because you won't have decimals. So what you will see sometimes, let me just pull up oh good gracious. Let me pull up a Desmos here so you guys can see it typed in. So instead of doing, like I could do pi, the easiest way to type in pi, it is in the menu, but if you just type pi, it'll turn into pi. Pi times 8 squared times 15. That's going to give you the volume as a decimal, but what a lot of times they'll do is they'll do 8 squared times 15. So there's two ways you might see the answer for this. They might call it 960 pi cubic centimeters, or they may give the decimal, and if we give the decimal, we will have, oh gracious, we will have 3015.929. And if you take 960 and multiply it by pi, you just get 3015. It's just sometimes they'll leave the answer this way on problems. Okay. Most students do well with these. This is not so terribly bad, right? Let's go on. Oh, wait. Let's see. Hold on. you what I've got so you understand what we're doing here. And if you know, like if you know for sure, don't tell anybody yet. Okay, so here I've got a cone and I've got a cylinder, right? And they have the same size base, so if you put those next to each other, the bases are the same size, and they have the same height, right? They're both the same height. So the only difference in dimensions for this is, or there's no difference in your dimensions. They have the same height, they have the same radius, but this one's a cone, this one is a cylinder. So here in a second for my demonstration, I am going to fill up my cone and pour it into my cylinder. How many times do you think it will take? All right, write down your guess. Write down your guess. How many times do you think it will take? I might need a paper towel so I don't make a huge mess here. All right. Okay. I'm going to put the document camera on here. Even though you probably wish the document camera had a different angle. All right. Okay. Now let's see if I can do this without making a mess. Probably not. Okay. That might not quite be full, but I'm going to spill it if I fill it up more. So there's one. Oh, I spilled just a little bit. Okay. There's. Still think it's going to be 2. Let's see. All right. Here is 2. It's definitely not 2 because we still got some room. It needs to be like, do you think it's going to be an even number?
No.
All right. Even though I think I have messed up a little bit here. Let's see. All right. I'm not picking that up because it's going to make a mess. But it was 3. Exactly. It's 3 exactly. You want to come up and look at it like it's just like domed over about to spill for that. It doesn't seem like it. It seems like it's 2. It seems like it should be 2, but it is 3. Did anybody guess 3? Did you remember it from before, or was it just your guess? All right. So, let's see if I can pour this back in here without making a mess. All right, now, I always try to do that for this to help you remember these formulas. So it takes 3 cones to fill up 1 cylinder. This is also a good reason if you ever go to the store and something is packaged in a cone. It's a little bit of a scam. It makes it seem like there's more there than there is. Like if you ever, usually it's more like, I don't know, sometimes there'll be like different snacks and stuff, and they'll be like a cone-shaped thing. There's a lot less in this than there would be if it were like a full cylinder, right? And it doesn't seem like it. It seems like it's almost as much, or at least like half as much, right? But if things are packaged in a cone, it's a third of what it would be if it's a cylinder. So that's something to keep in mind there. So, a cone is a 3-dimensional shape that narrows smoothly from a flat circular base to a point called the vertex or something else, and I don't know what was there. Let's see if I made these notes smart. Let's see. Come on. It's taking. And let me get you this note sheet. Let's see if I did this. Okay, that's what I was thinking. Apex or vertex. Okay. Vertex or apex. So, the volume of a cone is just a third of the volume of a cylinder, right? So, we need to add this to our, over this side. We need to add this to our note card, and Angel, pass that back to Hannah so she's got a note card. So, for our note card, let's add a cone. Okay, so a cone, I'm going to do my cone like upside down. I think it's easier to draw. Draw oval and just connect here. And a cone, you need, same as a cylinder, you need to know the radius and you need to know the height. It's important that height is like your vertical height. It is not the slanted side. And our formula here is 1/3 times pi r squared times the height. Okay, everybody got that on their note card? Okay, so for this picture, we need our radius and our height. What is the radius? 5. What is the height? It is 12. It is not 13. So it is your, like, whenever you're talking about a cone, it is like how high that is up off the table, right? The distance from here all the way down through the middle to the table. Or you can think of it over the side. It is not the slanted height, because once that's slanted, it makes it longer, right? So you want to use 12 for this. So the volume here would be 1/3 pi times the radius, which is 5, squared, times the height, which is 12. Now, there are two ways that they may do this for the answer. They may just type it in like it is. So they might just do 1/3 pi times 5 squared times 12. And so that gives us 314.159. Okay, and that would be in inches cubed, because our volume is always cubed. Or they may not include the pi. So if they don't include the pi, that means you just type everything but pi into your formula. So you'd have 1/3 times the radius squared times 12, and that'd give you 100. And you just put a pi with it, 100 pi inches cubed. You might see the answer given either way on that. I like just leaving pi in the answer, because then you don't have decimals. You don't have to worry about it. And especially whenever we get to things like our density and stuff later, it makes it easier to do like the next calculation that you've got to do. Okay. All right. A pyramid. In much the similar fashion, I'm not going to do it, but if I have a pyramid and a prism that have the same area of the base times the height. Now, this means for our pyramids, we are going to have a few different formulas on our note cards. Okay? And let's go back over to our note card. Okay? So for our pyramids, I'm not going to do quite as many for the pyramids as we did for the, so I'm going to make myself a line right here. Put pyramids here. Pyramids are especially difficult to draw. So what you can do for a pyramid to draw it is you can draw your base, like if we got a triangular pyramid right here, and then put a point somewhere up here like this and connect all of your sides like that to that point, or all of your vertices to that point. They're a little hard to draw. They're not easy to draw. Alright, so in this pyramid, I'm going to call this side right here my base. I'm going to draw me a dotted line right here that's perpendicular, and I'm going to call this my A for altitude, just because I don't want to use height twice. We usually use height. And then the height of the prism, or of the, not prism, of the pyramid, is like the height off of the table, not the slanted height, but the height that is from the table. So your volume is going to be 1/3 times, now I'm going to write two formulas for this. It's 1/3 times the area of the triangle, which is 1/2 times the base times the altitude times your height over here. But I said I was going to write that formula twice, because if I've got 1/3 times 1/2 base times altitude times height, what's 1/3 times 1/2? What's 1/3 times 1/2? How do we multiply fractions? We just did rationals. 1/6. Just multiply the top. 1 times 1 is 1. Multiply the bottom. 3 times 2 is 6. Right? So if you wanted, you can do 1/6 B times A times your height. That is, I should put triangular right here. Okay, for rectangular is tricky to draw because you don't actually like draw a rectangle on the bottom. You want to draw your base like a parallelogram because you're looking at it kind of like slanty. And so for rectangular, put your dot up here and connect all of your sides there. That looks pretty rectangular, kind of. It's not my best work, but it's kind of rectangular. Alright, so for a rectangle, your base is going to be length times width, and then you have the height of the pyramid, which is your height up off of the table, not the slanted height. So your volume is going to be 1/3 length times width times height. We're going to stick with those we are not going to do, like trapezoidal and parallelogrammal pyramids. Those will be way too difficult for us. All right, so let's do this one problem, and then we are going to do a few. You're going to do a few from your assignment, and then we're going to finish these notes some tomorrow because we've got lots. We're going to stretch this out into tomorrow a little bit as well. So if I'm doing this problem, first of all, what type of pyramid do I have? Okay, so I should have shown you these in a pyramid. I don't have as many pyramids, but I've got a few. In a pyramid, let me get some pyramids out here in my box of solids here. All right, so I've got 3 different pyramids here. This is a pyramid. This is a pyramid. This is a pyramid, right? What shape are all of your sides, your lateral sides in a pyramid? They are triangles, right? So the side that's not a triangle is your base, except if you've got this one, right? Then all the sides are triangles, and so your base is also a triangle. Now, the example that we're looking at, you'll see that you just want to use whichever base it's sitting on if it is a triangle, right? So this is your base triangle for this one. So we're looking at the triangle that is here for your base, and then the height is this 18. It's that dotted line that goes down through the middle, so it shows you how high it is up off of the ground. Right, so our volume formula is 1/6 times B times A times the height. For this pyramid, what is my B? What's my B? It's 13. That is my B. What's my A? My altitude. It is 15. It's this right here. That equals my A. What is my height of the pyramid? 18. Okay? So if we just type that in, 1/6 times 13 times 15 times 18 is going to give me 585. So 585 meters cubed. Okay? So, what I want you to do now is there is an assignment that you have on Desmos Classroom. So if you will go to students.desmos.com, there will be an assignment there. Okay? The first one is a matching one, and I really need to go back and change. I need to go back and change it so it's A and not H. Can I do that right? I don't think I can since you started it. Instead of an A, I used an H1, H2. I don't like doing that. I need to fix this, but I didn't. It only happens on the triangles right here. I did H1, H2 right there. Instead of doing A, and then I think I did it again on one other one. So you got a matching one first, and then I would like for you to do the first 2 problems. Okay, that's all you got to do. So you're going to go through slide number 4. Right, you got 7 minutes right now, so you should get a little ways on that, hopefully. It does not tell you if you get the matching will tell you if you got it right or wrong. The Other two will not for right now. So you only have to go through slide 4 just to get a little practice right now.